Hi, good afternoon everyone. Here I am going to explain the topic of flow through the open channels. And the subtopic is Kutters and Manning's formula for open channel flow. In the previous class we have discussed regarding the derivation of a open derivation for the open derivation of a Chassis constant for a open channel flow, and we have seen the simple problems on a Chassis formula. So in this class I am going to explain the different formulas we may use in the open channel flow, and we may see simple problems on Kutters and Manning's formula. So according to the Bayesian's formula, so Chassis constant for a open channel flow is C is equal 157.6 by 1.81 plus K by under root M. All these are the empirical formulas we may use in the determination of a velocity and discharge in an open channel flow. These are the Chassis constant. This is the Chassis constant according to the Bayesian's formula. This is the formula according to the Bayesian's formula. You may see here, this is the K is the Bayesian's roughness coefficient. It will be depends on the surface characteristics of a channel. So when we came to the Kutters formula, according to the Kutters, the Chassis constant C is equal 23 plus 0.00155 by I plus 1 by n all divided by 1 plus n by root m into 23 plus 0.00155 by I. All these are the empirical formulas. So here n is the Kutters coefficient depending on the surface of a channel. So next let's go for the Manning's formula. According to the Manning's, so it will becomes V is equal 1 by n into m power 2 by 3 into I for 1 by 2. So here n is the coefficient of a roughness. It is also equal to the Kutters constant. And also according to the Manning's formula, Chassis constant becomes C is equal 1 by n into m power 1 by m power 1 by 6. This is the Chassis constant. This is the Chassis constant according to the Manning's formula. So we will see the simple problems on Kutters and Manning's formula. So let's go for the problem number 1. Find the discharge through the rectangular channel 4 meters wide, having the depth of water 3 meters and bed slope 1 in 1500. Take n is equal 0.03. So using Kutters formula. According to the Kutters formula, he has given, so width of a channel B is equal 4 meters and D is equal 3 meters and bed slope is equal 1 in 1500 and Kutters constant n is equal 0.03. So according to the Kutters formula, here first we have to calculate the area of the flow 3 into 4 12 meters square. Wetted perimeter of a rectangular channel. Wetted perimeter of a rectangular channel, it will becomes B plus 2 into D, that will becomes 10 meters. According to the rectangular channel mean depth, hydraulic mean depth is equal M is equal to A by P, it will becomes 1.2 meters. So according to the Kutters formula, C is equal, we may substitute all the above values in the Kutters formula, then we can get, this is the Kutters formula. So in this we will substitute the above values in the Kutters formula, then we will get the discharge is equal Q is equal AC into root mi. Here we will get the discharge is equal ultimately 11.76 meter cube per second. According to the Kutters formula, the discharge becomes 11.76 meter cube per second. Next, let's go for the second problem. Find the discharge through a rectangular channel 2 meters wide and the depth of water 1.5 meters and bed slope is 4 in 8000. Take n is equal 0.012. Here we are using the Manning's formula. So he has given that width of the channel 2 meters and depth is equal 1.5 meter, bed slope is equal 4 in 8000 and kutters constant n is equal 0.012. So according to the Manning's formula, first we have to calculate the area 3 meter square and wetted perimeter 5 meter and hydraulic mean depth, it is a ratio of A by P. Here we will get that 0.6 meters of 0.6 meters. So according to the Manning's formula, P is equal 1 by n into m whole power 1 by 6. This is the formula. Here we will substitute the above values in this formula, then we can get that values are. So here Chassis constant C is equal to 1 by n into m for whole for 1 by 6. Here we have to substitute the above values in this formula, then we will get C is equal 30.56. According to the discharge, discharge is equal to Q is equal to AC into under root mi. Here we will substitute the above values in this formula. Here we will get 1.588 meter cube per second. This is the discharge according to the Manning's formula. Thank you.